Hi everyone, I'm back again. We're going to talk today about weight. So if you pull out your reference materials, we have already talked about customary capacity, metric volume. Those are the amounts of liquids in a container or the amount of a container can hold, the amount of liquid a container can hold. Down here is where we're going to be focusing our attention today and next week. Customary measuring system is what we're going to be using to measure weight. The metric measuring system is what we're going to be using to measure mass. We're going to be focusing today on customary weight. There is a difference, a big difference between weight and mass. Whereas I said before, there wasn't such a distinct difference between capacity and volume, at least for third grade, but for sure there is for weight and mass, and we'll talk about that a little bit, and then we'll get into our units of measure for customary weight. I'm going to read straight off of the website that I have pulled up the difference, and then I'll explain a little bit. The difference between mass and weight is that mass is the amount of matter in a material. So it's how much matter is actually packed in to a material or a substance. While weight is the measure of how the force of gravity acts upon that mass. So weight is all about how much gravity is acting on the amount of mass or the mass in the material. Now, one really good way, we did talk about this in science at the beginning of the school year, but one really good way to think about this is, let's say you are an astronaut and you are on Earth and you weigh yourself and you are 150 pounds on Earth. If you were to get in a spaceship and go to the moon, you would not weigh 150 pounds on the moon. Why is that? Because there is not as much gravity or gravitational pull on the moon. There is some, so you would weigh something, but not what you weigh on Earth. So weight is how much gravity is acting on the object, pulling it down towards the center of the Earth. So you would not weigh the same on Earth as you would on the moon. Mass is how much matter is in your body, when we're using this astronaut example. So if you were to measure your mass on Earth, then get in your rocket ship and go to the moon, you would have the exact same mass on the moon as you would on Earth, because you haven't lost any weight, you haven't lost any matter in your body. The same amount of matter is still in your body, so the mass would not change. This is just a very basic kind of distinction between weight and mass. So now we're going to get into our units of measure for weight. You've got 3 units of measure that you need to know. You've got ounces, which is the smallest unit that we'll be using. There are 16 ounces in 1 pound. Then the next largest units, we have our pound. So we're going to be talking also about tons. So it takes 2,000 pounds to equal 1 ton. So just those 3 units of measure: the ounce, the pound, and the ton. Now don't forget, I said this when we were talking about customary capacity. There's ounces that refer to weight, and then there is fluid ounces when we're talking about the customary measuring system. So please, if you're talking or if you're going to give me an answer with ounces as a unit, you need to distinguish between, are you telling me that the answer is blank fluid ounces or blank ounces? You need to distinguish between the two, because we now see that there are ounces being used twice here in this unit. So in your Go Math book, there's going to be a lot of questions referring to just like what unit of measure you would use to measure a slice of bread or to measure the weight of a large animal like a lion or a tiger. So just picking the best unit, the best measurements for weight is going to be really the extent of this unit. There will be some choice menus for you to be measuring some things around your house. Use a scale and see what you can figure out, the weights and the things, different things in your house. Have fun with it. Bye, guys.